In September 2016, close to 50,000 mining industry professionals from around the globe gathered in Las Vegas, Nevada for MINExpo International, the largest mining show in the world. MINExpo was the perfect venue for SKF to launch the first ever Mining Insights speaker series. SKF developed the series to help mining industry professionals gain insights to overcoming the challenges faced every day within the industry. A diverse range of experts from across the world of mining presented real-world case studies, industry trends, technologies for improving reliability, productivity, safety, and much more. And with that, I'm proud to present our next speaker, who is an expert on conveyor belt safety in the mining industry. He is the manager for Martin Engineering Company's Foundations training programs. He has led hundreds of workshops on conveyor belt design and operations, and we're very happy to welcome him to the SKF stand today. Please put your hands together for Jerad. Welcome to the stage, Jerad.
Thank you, John. Appreciate it. Thank you. Thank you. Good morning, everyone. As John mentioned, I'm here today to talk about conveyor belt safety. For the last 3 to 4 years, Martin Engineering has spent a tremendous amount of time scouring the globe for some of the best practices on conveyor belt safety. And we've incorporated those best practices in our latest publication, Foundations for Conveyor Belt Safety. This book is being introduced this week at the MINExpo show. We've got books here if you'd like one. If you have interest, let me know. But there'll be more on this before we finish this morning. How many of you guys have heard of Martin Engineering before? Many? When you've heard of Martin Engineering, what do you typically think of? Most of the time when you say Martin Engineering, most people think of belt scrapers and conveyor products, and we do that. But we do a lot of other things. And as John mentioned, we do a training program, and that's my role for Martin Engineering, is I manage a conveyor training program. So we teach miners the best practices, the techniques, to get the best performance out of those belt conveyors. A big part of that best performance is to make sure that those workers are safe when they work around those conveyors. There was a study that we often refer to from 2001 to 2006. This study was done by the U.S. Bureau of Mines. And in that time period, they found that there were 459 conveyor-related accidents to miners. 13 of those incidents resulted in a fatality. 22 resulted in a permanent disability to the worker. More interesting than that is to look deeper at this study and what those workers were doing. 42% of those miners that were injured, the miner was performing maintenance, lubricating, or checking a conveyor belt. 39% were cleaning and shoveling around the conveyor belt. That's 81% of all those conveyor accidents was from a miner either cleaning and shoveling or doing maintenance around the conveyor belt. If you look at the fatalities in the mining industry in the United States, they've declined. They've declined significantly, and that's what this graph shows. But when we analyze this a little bit further, you can see in most recent years, the fatality rate, as well as the injury rate, hasn't had a significant drop. It's kind of plateaued. So we really need to analyze this and understand, why are workers still getting hurt and injured at the same rate that they did even 20 years ago? There are hazards to the workers that work around conveyors, but there are also hazards to the owners of those conveyors. The hazards to the worker would include electrical hazards. They would include, of course, pinch points. Anytime that a rolling component meets that conveyor belt, it's going to create a pinch point, which would be a hazard to the worker. The conveyor belt has stored energy, We understand often the electrical energy, the hydraulic power that's accompanied by a conveyor, but what we often dismiss is the stored energy that's caused from the stretch of that belt. Of course, we've got moving material, and when material spills off the conveyor, when dust settles off the conveyor, that can create slip, trip, and fall hazards on the catwalk. There's confined space issues to workers that have to work around conveyors as well. One of the most significant and newest issues that we're going to be dealing with is the dust around conveyors. Because of the silicosis, the MSHA and OSHA response to silicosis and the measurement of silica dust, we know that conveyors generate a tremendous amount of dust. That's going to become a bigger hazard to the worker than it was even 2 or 3 years ago. And of course, noise hazards as well. The hazards to the ownership are typically much more expensive to the company than the hazards to the worker. They could include loss of production. They can include higher insurance rates after an incident. Regulatory problems, as well as unscheduled shutdowns, are going to cost the plant, the mine, tremendous amounts of money. Citations and fines, and damaged reputation to the ownership of that particular mine that might have had an incident. And then that damaged reputation is going to eventually lead to decreased profits. So we can analyze where the fatalities are from conveyor belts, and we've done that, and it's expressed in this new book that I mentioned earlier. And what we found is that there's fatalities and injuries all over the conveyor. However, the majority of the fatalities and injuries that you find around conveyors will typically happen at the tail pulley as well as the head pulley. So most of the incidents that we found, the worker was hurt while working in the head pulley area or the tail pulley area of the conveyor belt. So there's really 5 safety controls and 5 things that we can do to really reduce the worker risk to conveyors, as well as reduce the risk to the ownership of that conveyor. And these 5 things are in order of what we feel and what our research says are the most effective things you can do. So the most effective thing that you can do to keep your workers safe around conveyors is to find a way to eliminate the hazard. And when we first mention that, that can seem like a difficult task because we always believe that the hazards around conveyors are those pinch points and they're virtually impossible to eliminate. But we think a little bit differently, and I'm going to explain more to you on that in a moment here. But the most effective thing we can do is to eliminate the hazards on conveyors. Also, safety equipment. Safety equipment around conveyor belts would include backstops, would include emergency pull cords, and of course, guarding. And I'll talk both about e-stops or emergency stop switches and guarding in a moment. Policies, procedures, and protocol. Those are going to be your JSAs, your job safety analysis, your site-specific procedures, the site-specific policies that the management has in place that the worker must follow in order to make sure they reduce the risk. The fourth thing that you've got to focus on to keep your workers safe is to make sure you're investing in some sort of training. That training can be sending your miners to some sort of MSHA refresher course that's required by law. It might be bringing in some outside people. It might be as simple as having those more experienced miners spend time with those newer workers to make sure the newer workers understand what dangers are out there and how to mitigate those. And then finally, in our opinion, the least effective thing that you can do to keep a worker safe around conveyors is PPE. That doesn't mean we don't suggest it, that doesn't mean we don't support it, but in our opinion, it's less effective, far less effective than eliminating the hazard. So I want to talk very briefly about emergency stop switches. As I mentioned earlier, we've spent the last few years kind of going through different companies, different government agencies, and different global resources on what are the best practices out there on emergency stop switches. And our recommendations for emergency stop switches is that the movement in the cable should not exceed 12 inches. What that means is that cable runs along the side of the conveyor belt. That cable, once pulled a distance of 12 inches, should have activated or de-energized the conveyor, should have activated the switch or de-energized that cable before that cable gets pulled a distance of 12 inches. We recommend that the cable's got to be in good condition. So there should be a PM schedule where workers are going out on their conveyors, walking those conveyors down and inspecting those cables to make sure that those cables haven't deteriorated. They should also be inspecting the clamps. There must be 2 clamps, and those clamps must be installed correctly. The cable must run the full coverage of the conveyor belt. Now, some inspectors, some owners, some mine sites will only have that cable run along the side of the conveyor. We've already established that most conveyor accidents happen around the tail pulley or around the head pulley. So for that reason, we're going to recommend that cable runs completely around that conveyor, from the front of the head all the way down and around the back side of the tail pulley. We're also going to recommend that those switches be no more than 165 feet in distance from each other. This is a diagram that I got from our book as well. This is shown on the book, but one of the big questions that we have is how high should that cable be located? And our recommendation is that it should fall somewhere around 36 inches off the floor to no higher than 60 inches off the floor. One of the most effective pieces of safety equipment out there that you can do is to guard a conveyor belt. And in the United States, the guarding regulations and recommendations kind of all over the place. So we really put a lot of investment into trying to find some of those standards that other countries are doing that maybe here in the U.S. we can utilize. So the first recommendation for guarding is that we want to make sure that guard is not a hazard itself. One of the biggest problems that we see with guarding is that the guard's too heavy for a worker to handle. So our recommendation would be that a guard panel should be no heavier than 50 pounds. We want to make sure a worker can handle it, replace it back to where it belongs after he's done doing his work. We also want to make sure that there's no sharp edges, and we want to make sure that if there's hinges, that those hinges don't create a pinch point. We want to make sure that a worker cannot reach around a guard, under a guard, through a guard, or over a guard. So we use the acronym AUTO, A-U-T-O, as a quick reminder to make sure a worker can't reach around, under, through, or over that guard. The size of opening in the guard is something that we're going to mention as well here. I also want to mention that we do suggest that the guard require a tool to remove. Recently, MSHA has came out and stated that in the mining industry, they do not require a tool to remove the guard. The authors of our book are going to take exception with that. Every country in the world, every other organization in the U.S. that governs conveyors, that's a law. So our authors of the book took a took exception to that rule, took exception to that stance from MSHA, and our recommendation in the book is that any guard should require a tool to remove. The guard must stand out in color. It does not have to be orange, it does not have to be yellow, but it does need to be a different color than the equipment that it's guarding. And a practice that we've kind of been recommending lately is to paint the field of the guard, paint the mesh of the guard black. That black guard will allow for that worker to do a very quick and very thorough visual inspection of the equipment. However, the outer panel of that guard, if that's painted a very high visible color, orange or yellow, that guard stands out in color without impeding that worker's ability to make a visual inspection. The guard must be the proper distance from the hazard, and that's a reference in the size of opening. MSHA doesn't have an exact size opening that they've standardized. And again, the authors of our book have made a recommendation on the standard size opening, but I did want to share this. OSHA does have some machine guarding recommendations that could be used for conveyors. And it's a function of the size of the opening in the guard and how far that distance is, that guard is from the hazard. So that's what this chart shows you. If you look on one side, it's the distance of the opening from the point of hazard compared to the size of the opening in the guard. This is a picture that was shared with me the other day, and I wanted to make sure I pointed it out to you guys. And unfortunately, we see this way too often. And if you haven't been out looking at your conveyors in the last month or so, I'd suggest you get out there and you look at stuff like this. What these workers have done is, in order to test the vibration, they've cut an opening in that guard to make it simpler to get to it. Anytime a worker can bypass a guard for any reason, your risk skyrockets. Your risk as a mine operator or your risk as a mine worker skyrockets. So you got to make sure that workers aren't bypassing that guard. And it happens all the time. We also want to suggest some special considerations for return rolls. Any return roll should really be guarded. Now there is some regulations out there that says that if a return roll is above 7 foot in elevation, that return roll doesn't need to be guarded. That's another one of those exceptions that our authors took with MSHA. And our recommendation in our book is really any return roll really needs to be guarded, because when we're doing maintenance or working around that higher conveyor, we can then access it and then we put those workers at risk. The gaps between the guard and the belt have come into question recently. And you're seeing some manufacturers offer a piece that just runs in front of the pinch points where the belt meets that return roll. And we still feel that that gap needs to be guarded, and you need to make sure that that piece that runs along there is close enough to the belt. And our recommendation would be that that gap should be no more than 3/16 of an inch. So here's an example of a plant that I was at. They did a good job. They guarded their return rolls. They did a pretty good job at returning their return rolls. But if you look at that gap between the guard and the belt, it's far more than 3/16 of an inch. So it's really not effective. So we talked about safety equipment. We need to also mention policies, procedures, and protocols to keep workers safe. So just very briefly, I want to mention that any policy, any procedure, and what we're typically referring to is a lockout, tag out, test out, and in some cases a blackout procedure. Management really needs to establish and teach those procedures. It's the mine manager's responsibility to make sure that supervisors and the leads know, understand, and share those policies and teach those policies to their workers. Then of course it's up to the worker to make sure that he follows, knows, understands, and abides by those policies and procedures. The only way these policies or procedures can be effective is if the mine takes a zero tolerance stance to it. So if you have a worker who disobeys or doesn't follow the procedure as it's supposed to, you really have to have zero tolerance in order for that procedure to stay effective. One of the unknown concerns about conveyors that I wanted to mention is a blackout procedure. Earlier in the day, I talked a little bit about the stretch of a conveyor belt. The head pulley or the drive pulley typically grips and pulls that belt. Therefore, there's more stretch at that point of the conveyor than in other points of the conveyor. When you have workers working in that high stretch, simply locking out and tagging out a conveyor may not reduce or eliminate their risk of injury. In many cases, those workers will also have to establish what they call a blackout procedure. And that's what you see in this picture on the right hand of the screen. This is a belt clamp that simply clamps onto the belt. It's rigged to the frame of the conveyor, and it keeps that belt or the stretch of that belt from being released unexpectedly. That brings me to training. And training is so often underutilized at most facilities. And we're dealing with guys that have been working around the mines for 20 years, and we forget that he can still learn something. And we often forget the power that training might have. So we did a study. We looked at a gentleman a few years ago. His name was Donald Kirkpatrick, and he was a professor at the University of Wisconsin. And we try to model and recommend training programs that abide to Donald Kirkpatrick's model of evaluating a training program. So what he said is that first and foremost, the trainee must have a reaction to the training. He must feel that that training had meaning, and he must feel that that training can have an impact on what he does in his job. Once that happens, that learner can then elevate to level 2, which is simply learning the information and retaining the information. Once that learner retains the information, he can then reach to level 3. And level 3 is then he can have a reaction to it. He can have a behavioral action to what he's learned, or he can incorporate what he's learned. Finally, once he's incorporated, what he has learned, then and only then can the mine experience any results. And once they experience those results, they can measure it and make sure the investment on that training was worth it. So any training evaluation, you really have to understand that there is no value in training at all unless the learner goes through each one of those steps, has a reaction, retains the information, implements the information, then and only then can that action have impact on the mine's success. So just a couple of training best practices that we'll share with you. Every year, any miner is required by law to have annual MSHA refresher training. Training is undervalued and underperformed. Learners' own experiences must be incorporated. I had a conversation in our booth yesterday with a guy who was looking for some conveyor training, and he said, do you guys offer hands-on stuff? And we do. However, typically our recommendation is that training done in the classroom can be, and in most cases is, more effective than hands-on training if that classroom training is done right. And what we mean by done right is that, are we incorporating those adult learners into the conversation? Are we letting them share their experiences and leading a discussion rather than just lecturing to them? Training must be enjoyable for the learner, it must be educational, and it must be engaging. So earlier I mentioned that there's really 4 measurements, there's 4 safety controls that we try to focus on. And this diagram shows those 5 things in order of effectiveness. And earlier I told you the most effective thing that we can do to keep workers safe is to eliminate the hazard. When we really start to think about that, it may be difficult to eliminate the hazard unless we really analyze what that miner was doing. And we said earlier that there was a study by the U.S. Bureau of Mines that said that 81% of all the accidents that they researched, the worker, the injured, was performing maintenance or cleaning and shoveling around a conveyor belt. So, if we can reduce that cleaning and shoveling around a conveyor, if we can make maintenance quicker and easier, that's one way, and the most effective way, that we can reduce the hazard. So the hazards on conveyor, in our opinion, aren't necessarily those pinch points. However, they are the carryback that workers have to clean around. It is the dust that settles that the workers breathe in and have to clean up, and it's the spillage at the transfer points that a worker is forced to clean up, putting him at exposure unnecessarily. So the best way to reduce injury or reduce risk is, in our opinion, by reducing fugitive material and keeping the workers that work around those conveyors much safer. So I mentioned to you guys earlier that, we came out with a new publication. This is our Foundations 5. This is on conveyor belt safety. And if anybody wants a copy of this, we'll be happy to share this with you for your time today with us. So if you stop at our booth at 4:15, we'll be happy to give one of these to you. The author of the book is here as well. So if you have any particular questions, he can share this with you. And also, if you haven't used this or seen this, this is our previous publication. And this is more of a practical, hands-on recommendations on how to get best conveyor performance. This particular publish is on conveyor safety. So thank you to SKF for having me here today. John?
Okay, Jerad, thank you. Please put your hands together for Jerad.
Thank you.
Thanks, Jerad. Very good. Just an observation. I think that was a very enlightening presentation, a very serious presentation, and I think the message is very clear. Just an observation though, you referenced the Foundations for Conveyor Safety book, which is clearly a comprehensive book for all the right reasons. But is there a more simplified version that you could reference today?
When you look at that book, it seems it's 600 pages, and a simplified version or quick reference would be good, but that book is organized in a very useful way. So every chapter we have listed some quick, here's our recommendations. Now we analyze all those recommendations and all those practices in each chapter, but in each chapter it is simplified throughout that book. Also, that book, part of that book is the global best practices, but one of the things that we found, one of the things that our authors of the book would mention is that it's virtually impossible for safety managers, plant managers, to get the capital money to do the improvements that they need to do or want to do to improve the conveyors. And a very large portion of that book is the financial justification for safety investments.
Okay, very good. Thank you, Jerad.
Thank you.
Thank you. Very good.
Join the conversation. If you haven't already, be sure to follow SKF Mining Insights on LinkedIn and look for more case study presentations and other valuable content on skf.com/mining insights.